Guys, welcome to my YouTube channel. Welcome to ETA. This is the channel whereby we bring you the best in maths, physics, and chemistry. So guys, if you haven't subscribed to my YouTube channel, please do so and don't forget to click the notification button so that you can get more content when we upload. Now guys, I'm gonna be teaching you guys an interesting topic in physics, electrodynamics. Now the title says it all. There's there's electricity, and there's also the word dynamics. Dynamics means movement. It means there is a relationship between electricity and movement. So we're gonna start by introducing Faraday's law. Now Faraday's law says, it says whenever there is a conductor moving in a magnetic field, electricity is induced. So hence the name electrodynamics. So whenever there's a movement, a moving conductor within a magnetic field, there is electricity that is created. So we have three factors here. We have the movement or the force. We have the magnetic field. We have the force. We have the magnetic field. We also have magnetic field. We also have the current induced. Now, in order to figure this out, you need to use your right hand rule to figure out how the current is induced. Now, it means whenever you're moving a conductor in that direction, within a magnetic field which is pointing in that direction, your current will go in that direction. Let's say if you're using a right hand, this will be your thumb. And then this will be your pointing finger. And then if you fold your smaller finger, it will point in this direction. So that's all we have. Now, according to Faraday's law, we know that the, induced, the, 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 EMF is given is directly proportional. Sorry, it's directly proportional to the magnetic field. The magnetic field, that's the magnetic field, divided by the rate at which the magnetic field is changing, or it's moving, it's moving, the rate at which the conductor is moving within that magnetic field. So if you move your conductor fast, you will induce a higher voltage or a higher EMF. Therefore, your EMF is given by the following. We introduced a constant here. And this constant is actually the number of turns. Your N is the number of turns on a coil of the conductor. Right. Now, sorry, there's a negative. I forgot. Now, the negative on the formula, the negative, it shows that the induced current is opposite the change in magnetic field. Okay. All right. Now, what we know about the magnetic field is that it moves from north to the south pole. Now, whenever there's a change, or whenever there's a motion of a conductor in between the magnetic field, a voltage is induced. However, this voltage is induced in cycles. So this will be a full revolution, guys. 180, 360. So when the coil is at 0 degree to the magnetic field, when it's at 0 degree to the magnetic field, there is no induced voltage. However, when your conductor is at 90 degrees, you get a certain voltage. You get a voltage, Vmax. When you turn the coil back to 180 again, you don't get any voltage. So that's what happens. And then we also have the following different types of rings. Now, We have a split ring, which is used, the split ring commutator, which is used to turn AC to DC. Now for AC, a slit ring is used. Okay. Although I won't be able to draw the whole setup, I'm not that good with it. All right, guys. Now, what are the advantages of AC? AC current. Now, the advantages of AC current is that a transformer can be used to change a potential difference. However, what we know is that the power remains constant. The power remains constant. So power, which is voltage by I, it remains constant. So if we step up the voltage, the current will go down. The two will balance each other, and the power will be constant. Now we have step up transformer. So the step up transformer increases the voltage. So the step down is actually the opposite. And the other thing that is very important when transmitting electricity, we must use thick conductors to avoid overheating due to resistance of the conductor. All right, that helps. Now, the voltage that is produced, as we have said, it goes in circles. However, the voltage that we get at home, or the effective voltage, in which in electrical terms we call it the root mean square. It is given by, let's say, if that's your V max, this is your V root mean square. This is the V root mean square. So it is given by your V root mean square is given by V max over the square root of 2. Same thing with current. I max divided by the square root of 2. Right, guys. That's all I could give for you guys today. Now, if you haven't subscribed to my YouTube channel, please do so. so that you can get more content, especially when I start doing examples. So guys, thank you. On for the next one.